Today we will see a problem statement on a search for a puzzle solver. Solve the 8 puzzle using A star search, and we will define the heuristic function h1, that is number of misplaced tiles, and h2, that is sum of Manhattan distances of all tiles from their goal positions. So we will implement A star with both heuristics, compare the performance of the two heuristics in terms of the number of nodes explored and the solution depth. So now let us look at the implementation. So first of all, we are using the tkinter for better visualization. We are defining the goal state, and then we are defining the move function for up, down, left and right in the 8 puzzle. So we are getting the neighbors using these directions. Then we are defining the first heuristics, that is number of misplaced tiles, as if state ij is not equals to 0 and state ij is not equals to goal state, then misplaced plus equals to 1. And the second heuristic is the sum of Manhattan distances. So that is the distance plus is equal to abs of I minus goal underscore x plus abs j minus goal underscore y. And our A star search implementation is given here. So we use a frontier or a priority queue to find the lowest cost, and explode set it keeps the visited nodes, and so we add to the explode whatever we have visited, and then we explore the neighbors, and we then calculate the total cost as the cost g of n. This is g of n, and this is h of n. So in the A star search, the actual cost is calculated as a sum of f of g of n plus h of n. So we put that then in the frontier. So this is the implementation of the puzzle visualizer puzzle. So we have used some buttons: solve with h1, solve with h2, step and reset. Then we draw the puzzle grid structure. Then we have a method solve underscore h1, and and solve underscore h2 similarly, and the step underscore solution and a reset button, and we then run the program. So we give a start state randomly. We can change it here 1 2 3 4 0 6. So we can change the start state. Now let us run it. So this is our puzzle, and if we say solve with h1, so path cost is 1, step involved is this, and suppose we reset and solve with h2, so the path cost is also 1. Now if suppose we want to change to some other state, say we place here 0 and 2 here, and then we run it. Okay, so now our initial state has been changed, and then we solve with h1, path cost is 2, and solve with h2, similarly the path cost is 2. So we can change the initial